So very quickly, when we talk about equation of a circle passing through 3 points, let's say we have our coordinates, the x and y, and then we'll have our circle. Now for this circle to pass through 3 points, assuming we have a point here, probably a point here, and then a point here. So we have this, for example, it can be this way, all right? Now, at every point we have the x, we have a coordinate x, comma, y, right? So let's call here x2, y2. Then let's call here x3, y3. So you see this circle touches 3 points. And then how do we find the equation of a circle passing through 3 points? Now, substitute. What do? We substitute each point into the general equation. That's the first thing to do. That's the effort. We take the first point, x1, y1, substitute the values into the equation, write it down. Do the same for x2, y2, and then x3, y3. So at the end of the day, we're going to have 3 equations in 3 unknowns, the G, the F, and the C. So we solve simultaneously to find that G, F, and C. So very quickly, let's look at an example, after which we move over to tangent. We have says find the equation of the circle passing through the points 1, 2, minus 2, 1, and then 3, 4. So the first point is our x1, y1, the second our x2, y2, the third our x3, y3. So first thing to do, write down the general equation of a circle, and that is x squared plus y squared plus 2gx plus 2fx plus c is equal to 0, right? Good. So now, after writing down the equation of a circle, pick the first point, that first coordinate x1, y1. So anywhere I see x, I will put 1. Anywhere I see y, I will put 2. So that will be for 1, 2, coordinate 1, 2. I will have 1 squared plus 2 squared plus 2g times 1 plus 2f times 2 plus c is equal to 0. So 1 squared will give us 1, 2 squared will give us 4, 2 times 1 is 2, so we have 2g, 2 times 2 is 4, so we have 4f plus c is equal to 0. So let me leave the constants, the 1 and 4, and then write 2g plus 4f plus c. So 1 plus 4 will give me 5. So take that 5 over to the other side. I have minus 5. So let me call this equation 1. So doing the same thing for the second point, minus 2, 1, I'll have minus 2 squared plus 1 squared plus 2g times minus 2 plus 2f times 1 plus c is equal to 0. So minus 2 squared will give you 4 plus 1. 2 times minus 2 will give you minus 4. So we have minus 4g here plus 2f plus c is equal to 0. So just like we did in the at the first point, we have minus 4g plus 2f plus c. 4 plus 1 will give us 5. So take it over to the other side. We have minus 5. So we call this equation 2, right? So now for the third point we have 3 comma 4. So let me write out the points so that I'll be seeing my x and y coordinates as I substitute. So I have 3 squared plus 4 squared plus 2g times 3 plus 2f times 4 plus c is equal to 0. All right, so we have 9 plus 16 plus 6g plus 8f plus c is equal to 0. So just like we did in the previous equations, 6g plus 8f plus c will be equal to 9 plus 16 will give us 15. So, sorry, will give us 25 rather. So when we take 25 to this side, we'll have minus 25. So we label it equation 3, right? So now I'm going to write out the 3 equations together so that we can be seeing the equations together while we solve. So the first we had 2g plus 4f plus c to be equal to minus 5. That was our first equation, right? Okay. So it has to maintain that name, equation 1. Then for the second equation, we had minus 4g plus 2f plus c to be equal to minus 5. I'm just writing out the 3 equations so that we can see them at once and then know what to do. And then the last one, 6g plus 8f plus c is equal to minus 25. So this is our third equation, right? Okay, now there are 2 ways to solving 3 linear equations simultaneously. What's the first way? There may be other ways anyway, but these 2 are the 2 methods I use. 1, I can decide to subtract maybe the third equation, for instance, from both equation 1 and 2, and then solve simultaneously. Do you understand? You know, when I subtract equation 3 from 1, C goes. When I subtract equation 3 from 2, C goes. All right? So I will have just 2 linear equations to solve simultaneously for G and F. There's a mistake here. This should be F. Do you understand? Good. Then another way which I'm going to use now is I can actually, let me pick equation 1, for instance, and then make C subject. Using equation 1, if I make C subject, that means I'm going to take 2g to the other side. So I'll have minus 2g. Then 4f becomes minus 4f. All right. So now making C subject, I will substitute it into equation 2 and 3. Remember that I just rewrote equation 1, making C the subject. All right. So substitute into equation 2 and 3. So anywhere I see C, I'm going to substitute that expression. Okay, so for the second equation, it will become minus 4g plus 2f plus, so instead of me having C, I will have minus 5 minus 2g minus 4f is equal to minus 5. So going further, if I collect like terms, minus 4g minus 2g will give us, because it's plus that is opening the bracket, so plus times minus, the minus will still be retained. So we have minus 6g plus 2f minus 4f becomes minus 2f. Okay, so we have minus 5, right? So if minus 5 goes over to the other side, it becomes plus. So minus 5 plus 5 will give us 0. Okay, so now let me call this one A, a baptismal name. Let's call it A. Then doing the same thing for equation 3. In equation 3, we'll have 6g plus 8f plus, so what's my C? Minus 5 minus 2g minus 4f is equal to minus 25. So we collect like terms and then we'll call it B. Why I'm giving it a name is that so that we'll know the equations we'll be solving for G and F. So now 6g minus 2g will give us 4g. 8f minus 4f will give us 4f. Right? So on the other side, we have minus 25 already. So if you take minus 5 over, it becomes plus. So here we are left with 20. So we call this equation B. So let me just write the A under it. Minus 6g minus 2f is equal to 0. And that's our equation A. Okay? So now looking at this equation, solving simultaneously, probably using elimination method, we're going to be making one of the coefficients in one of the equations to be the same with what we have in the other equation. Okay, so in equation A, let's say we multiply here by 2. All right, so that we'll have 4 here, just like we have here. So that will become minus 12g minus 4f. 2 times 0, 0 will still be 0. Then that one up, that's our equation B. Let me just write it under. So we have 4g plus 4f, because I want to add the two equations together. So adding the two equations, I hope you know why I'm adding, because the coefficient of f, they have different signs. When the signs are different, you add. That's if you want to eliminate that variable. But when the signs are the same, that's when you subtract. Okay, so minus 12g plus this will give us minus 8g. So f has been eliminated. So 0 minus 20 will give us minus 20. So to find g, we divide both sides by minus 8. So our g becomes 4 into 20 will give us 5. And then 4 into 8 will give us 2. So our g is 5 over 2. So solving for f, I'm going to substitute 5 over 2 into any of these equations that I just solved. So let me use the last one. I have 4 into 5 over 2 plus 4f is equal to minus 20, right? So 2 divided 4 will give us 2. So we have 10 plus 4f will give us what? Minus 20. So if we are collecting like terms, taking 10 to the other side would become 4f is equal to minus 30. So we divide both sides by 4. And that will give us minus 15/2. Okay, so the thing that we are left with is what? Is our C. All right. But then remember that equation that says that C is equal to minus 5 minus 2G minus 4F. So substituting the values of G and F here, we'll have that minus 5 minus 2 into 5/2 minus 4 into minus 15/2. So what's our C going to be? We'll have minus 5. So these two will cancel this. So minus 5 minus 5. Minus times minus is plus. 2 here will give us, cancel 4 will give us 2. And then 2 times 15 will give us 30. So minus 10 plus 30 will give us 20. Okay, so our C is 20. So now what will our equation look like? Same thing will happen here. So we have the equation to be x squared plus y squared plus 5x minus 15y plus 20 is equal to 0. So I believe this is clear. Please, anywhere you see a question that has to do with this comes out in WAEC. I think this is a WAEC question. What will be that equation of a tangent at a point x1, y1? So at that point, we have a coordinate x1, y1. All right. So now differentiating implicitly to find that rate of change, we'll have differentiating this with respect to x, we'll have 2x plus differentiating this, we'll have 2y dy dx plus 2g plus 2f dy dx. So for C is 0. So we have equal to what? 0. Differentiating a constant gives you 0. So every term here that has dy dx, we leave them on this side of the equation. Plus 2f dy dx then taking other ones to the other side, we'll have minus 2x minus 2g. Now on the left hand side, we have dy dx to be a common term. So if we factor out dy dx, we're going to have 2y plus 2f to be equal to minus 2x minus 2g. So we're looking for that change in y with respect to the change in x. So divide both sides by 2y plus 2f we'll have our dy dx to be equal to minus 2x minus 2g all over 2y plus 2f, right? Now this dy dx, this change, recall that dy dx is that change, that's y minus y1 over x minus x1, and that is equal to what? Okay, now I've actually forgot to do something here. 2 is common in the numerator and the denominator. So I can actually factor out 2, and then I have my minus x minus g, right? Yeah. Factor out 2 again in the denominator, I have y plus f. So the 2 cancels out, and then I have minus x, y minus y1 times y1 plus f is equal to x minus x1 times minus x1 minus g. So if you expand, if you open up these brackets, you're gonna have x1 plus y1 plus g into x plus x1 plus f into y plus y1. So now the question is, what really changed? This is equal to minus x1 squared plus y1 squared. So we say let C be equal to minus x1 squared plus y1 squared. So now what is really the difference between which equation is it going to form? Good. So now we have equation of a circle when it touches a tangent to be, or when a tangent touches a circle, the equation formed to be xx1 plus yy1 plus g into x minus x1 g into x plus x1 plus f into what? Y plus y1. Plus 116 plus 48y minus 285 is equal to 0. So now why are we comparing? Now from the question, we already know our x1, y1, but we do not know our g, our f, and our c. I mean, for the equation of a tangent, which we wrote down first. All right, so we have to compare so as to obtain our g, f, c, and then substitute there to find the equation. All right, the equation of tangent to that very circle. So now if we compare these two equations, the coefficient of x is 2g, and then the coefficient of x in the second equation is 116. That means g, which is 116 over 2, is equal to 58. Now the coefficient of y in the first equation is 2f, and then the coefficient of y in the second equation is 48. So dividing both sides by 2 to obtain f is going to be what? 24. All right. So what about c? Our c is minus 285. Okay. So now when we substitute this into the equation, remember that the point is 2, 1. That's our x1, y1. So substituting into that equation of tangent to a circle, we're gonna have, so our x1 is 2, so we'll have 2x plus y times 1, we'll have y, plus our g is what? 58. 58 into x plus 2 plus 24. 24 into y plus 1 minus our c, which is 285, is equal to 0. So simplifying, we will have 2x plus y. 58 times x will give us 58x, plus 58 times 2 will give us 116. 24 times y, we have 24y, plus 24 minus 285 is equal to 0. So if we collect like terms, because there are like terms to collect, 2x plus 58x will give us 60x. Y plus 24y will give us 25y. Okay, then 116 plus 24 minus 285 will give us minus 145 is equal to 0. But then if you look at this equation, it can actually be reduced, right? So if I divide through by 5, 60 by 5 will give me 12. So I have 12x. 25 divided by 5 will give me 5y. And then 145 divided by 5 will give me 2. 9 is equal to 0. As simple as ABC. So please, when you see these questions in WAEC, wherever, please just comfortably take care of it and just give me feedback. If you need more clarifications, please do not hesitate to reach out. Thank you for joining us, and please do well to watch out for our next video as we deal with conics, ellipse, parabola, hyperbola. Bye.